very good morning to one another. I am Dr. Nalla, working as a professor under Department of Pharmaceutical Analysis at SNS College of Pharmacy and Health Sciences at Coimbatore. Today, the case study based lesson, we learned about visible spectroscopy. The visible spectroscopy synonym is colorimetry. It has wide application in the pharma industry under this quality control department. So, very selective drugs or a colored compound or a colored API or during the formulation or a synthesis, if the API or the active content got produced any coloring compound, such compounds specifically we can estimate with the help of visible spectroscopy. So around the visible range above 400 to up to 950 nanometer we are using. In this, today we learned about the visible spectroscopy principle and working principle, instrumentation. Under this instrumentation, each compartment importance also we learned, and after that major applications of visible spectroscopy in the pharmaceutical industry we learned, and advantages, disadvantages, limitations also my students learned. So we are going to project this session as a case study based evaluation session. I hope this video is useful for the B.Pharm or pharmaceutical learners. Thank you. My students will continue this case study based activity. Thank you.
Hello, I am Balamurgan. I am studying SNS institution. I like to ask questions about colorimetry. And question number 1. Colorimetry is based on which principle? Option A, absorption. Option B, scattering of light. Option C, reflection of light. Option D, refraction of light.
Option B, absorption of light. Question number 2. Lambert's law states that absorbance is directly proportional to option A, path length only, option B, concentration only, option C, both concentration and path length, option D, wavelength.
I would like to answer. The correct option is option C, both concentration and path length.
Which type of light is commonly used in a colorimeter? Option A, ultraviolet light. Option B, infrared light. Option C, visible light. Option D, X-rays.
Let me answer option C, visible light.
The wavelength range of visible light used in colorimetry is option A 200 to 400 nanometer, option B 400 to 700 nanometer, option C 700 to 900 nanometer, and option D 100 to 400 nanometer.
Option B, 400 to 700 nanometer.
Which component is used to select a specific wavelength in a calorimetry? Option A, detector. Option B, light source. Option C, filter. Option D, photoscope.
I like to answer. Option C, filter. And next question, 6th question. The intensity of transmitted light is measured by option A, filter. Option B, cuvette. Option C, photocells. Option D, light detector.
Let me answer. It's option C, photoscope.
7th question. The relationship between absorbance and transmittance is option A, A equal to T, option B, A equal to 1 by T, option C, A equal to minus log T, option D, A equal to log T.
Option C, A is equal to minus log T. Which cuvette material is commonly used in colorimeter? Option A, quartz. Option B, plastic only. Option C, glass. Option D, metal.
I would like to answer. The correct option is option C, glass. Colorimetry is mainly used for estimation of option A, volatile substance, option B, colorless gases, option C, colored compounds or colored solutions, and option D, radioactive substance.
It's option C, colorless solutions.
Last question. Which factor does not affect the calorimetric analysis? Option A, wavelength. Option B, concentration. Option C, path length, and option D, pressure.
Answer option D, pressure.
Thank you.
Yes, I hope this case study based session about this visible spectroscopy. It is very useful for you. And here in the next case study, we are planning to compare this visible spectroscopy with UV visible spectroscopy. So what are the limitations we have in this UV visible spectroscopy and what are the limitations we have on this visible spectroscopy? Both we will compare, and finally we can conclude merits and demerits and advantages. Compare when UV spectroscopy, what are the advantages we have in this visible spectroscopy, we can conclude. And so this visible spectroscopy widely we are using in the pharmaceutical industry to find out or to estimate the quality or a purity or a percentage purity of active content. Many synthetic drugs we can find out the percentage purity or amount present from the different dosage forms with the help of visible spectroscopy for selective molecules. If the compound is a colorless, we can use UV spectroscopy. It's a colored active content, we can use only visible spectroscopy. So these things we was clarified today, and we will meet in the next case study based session soon. Thank you.